Number 2, a 4-cylinder 4-stroke cycle 20 cm by 25 cm by 550 rpm diesel engine has a mean effective pressure of 150 psi. Calculate the brake power if the mechanical efficiency is 88%. So, ito yung given natin. Number of cylinder is 4. Then, 4 strokes, so K is 1/2. Diameter 20 cm, convert lang natin, that would be 0.2 meter. Length 25 cm, so i-convert, we have 0.25 meter. And engine speed 550 rpm. The mean effective pressure 150 psi. Binigay ang mechanical efficiency 88%. Ang required is the brake power. So, ganun ulit, since brake power yan, ang ating formula would be mean effective pressure na brake times the volume displaced. Kaya lang, hindi binigay ang brake mean effective pressure. Hindi malinaw. Ang binigay lang, mean effective pressure. So, kapag ganyan yung given, tandaan natin, that can either be brake or indicated. Okay, so ito yung pwede natin tingnan. Since may binigay na mechanical efficiency sa problem, imagine na lang, kung ang given is inassume natin brake, hindi natin gagamitin yung mechanical. Ganun yun. So, dahil may binigay na mechanical efficiency, ang mangyayari sa mean effective pressure, yan ay magiging indicated. Para lang magamit yung binigay na mechanical efficiency. Okay, therefore, dun sa formula natin, wala pa tayong brake mean effective pressure. Kukunin natin yan. So, balik tayo sa mga diniscuss nating formula. Okay, kung titingnan natin, ang mechanical efficiency is brake over indicated. Then, at the same time, pag tumuloy tayo, pag dinefine mo yung indicated at brake, parehas pressure, volume displaced. Kung titingnan mo sa formula, ang nagbago lang is yung mean effective pressure. So, pag pinagsama natin yung kanina na formula at itong dalawang ito, lalabas ang equation na to. So, pwede natin sabihin na ang mechanical efficiency pwede ring brake mean effective pressure over indicated mean effective pressure. So, ganun pa rin naman, brake over indicated. Then, substitute muna natin. Okay? Then, since ang ang unit natin sa problem, dalawa, gawin nating SI na lang. So, yung PSI, convert natin. And cancel yan. So, lalabas ang brake mean effective pressure, 909.86 kilopascal. So, kung nakuha na natin yan, substitute na natin dito sa ating working equation. Take note, ang volume displaced is length. So, hindi ko na ilalagay, no? So, para ma-practice din, kaya tandaan yung formula, then substitute natin. So, daan-dahanin naman natin. We have the brake power equals 909.86, that is the brake mean effective pressure. Then, ang volume displaced is length, ang L, yung stroke, we have 0.25. Then, area, pi over 4, diameter, 0.2. And revolution, 550. Kaya lang, since SI, tandaan din to, pag SI, gagawin natin per second. Kaya divide by 60 yung minute. Then, number of cylinder 4, piston action 1. Okay, dahil 4 stroke, we have 1/2. So, lalabas ang brake power 131.01 kilowatts. Number 3. A certain diesel engine with the following specifications: 8-cylinder, 400 mm by 600 millimeter. 4-stroke cycle has a fuel consumption of 0.60 pound per horsepower hour based on 19,100 BTU per pound. Engine speed is 280 RPM with an indicated mean effective pressure of 130 PSI. If the jacket water carries away an estimated 25% of the heat supplied, find its capacity in gallons per minute required if the allowable rise is 40 Fahrenheit degree. Okay, given we have 8 cylinder, diameter 400 millimeter, that is 0.4 meter, stroke 600 millimeter, that is 0.6 meter. We have 4-stroke, K is 1/2. Fuel consumption, we have 0.6 pound per horsepower hour. Heat supplied 19,100 BTU per hour. Speed 280 RPM. Indicated mean effective pressure 130 PSI. Okay, binigyan tayo ng condition. Ito yan. Yung heat absorb ng ating cooling, yung water jacket, 25% ng heat supplied. And yung temperature rise, 40 Fahrenheit degree. The required is the volume flow rate ng water. Ang solution natin, yung formula din, manggagaling dun sa water since yun ang inanap. Volume flow rate ng water, so didefine natin yung water. Ito yung heat absorbed ng water, MC delta T. And take note, ang mass flow rate is density times the volume flow rate. And at the same time, binigay sa problem, yung condition, ang heat absorbed ng water is 25% ng heat supplied. And by definition, ang heat supplied is the product of fuel and the heating value. So, yun yung magiging solution natin. Kaya lang, hindi pa natin ito magagawa kasi wala pa tayong mass ng fuel. So, yung mass ng fuel, makikita natin yun sa fuel consumption. Okay? So, sa problem, binigay ang fuel consumption. Hindi sinabi din kung indicated or brake. Parang sa nakaraan, ganun yung pressure. So, hindi naman natin pwedeng sabihin, ito yung brake kasi there's no way na makakukuha tayo ng indicated unless may binigay ulit na mechanical efficiency. Okay, so since walang ganun, etong nasa given, i-assume na natin yan na indicated fuel consumption. So, ito yung formula. Okay, wala pa tayong power ulit, indicated. So, didefine natin yan. Ito yung formula. Okay, pinalitan na natin yung volume displaced yung pinaka-definition niya. Okay? Para mas makita. So, substitute yung ating unit na PSI, gagawin natin kilopascal para maging SI, hindi malito tayo sa units. Then, lalabas ang power indicated 1,261.16 kilowatts. Once na makuha na natin yung power, pwede na natin yung i-substitute dito sa formula ng fuel consumption para makuha natin yung mass ng fuel. So, ibabalik natin yan dito. Ito ngayon yung ating solution. Substitute natin. Then, lagay natin yung mga unit analysis. So, since ang fuel consumption ay naka-horsepower, then yung ating power is kilowatts. Either of the two naman pwede natin gawin. Okay, conversion, we have 0.746 kilowatts per horsepower. So, cancel ang kilowatts. Cancel din ang horsepower. Then, para mas mapalit natin yung value, yung R, gawin natin minute. So, we have the conversion. Cancel yung R. So, lalabas ang unit ng mass ng fuel, pounds and minute. So, we have the value 16.90 pound per minute. Yun na yung mass ng fuel. And yung mass ng fuel, pwede na natin substitute dito. Siguro, pwede na natin ipunta dun sa ating working equation. Diretso na natin. So, eto na yung magiging solution. Sundan lang natin tong flow na to, para di mawala. So, we have 0.25 ng supplied. Ito yung mass ng fuel. Then, yung ating heating value. Okay, so at the same time, yung mass ng fuel, we have the density. Ang density ng water, since water ang pinag-usapan dito, is 8.34 pound per gallon. Okay? And at the same time, yung kanyang specific heat is 1 BTU per pound Fahrenheit degree. Okay, cancel yung pound. Then, cancel BTU. Cancel yung isa pang pound. Cancel Fahrenheit degree. So, may iwan yung unit ng gallons sa minute. Lalabas ang volume flow rate ng water. That would be 241.90 gallons per minute na yan. Number 4. A 4-stroke, 8-cylinder diesel engine with bore and stroke of 9 inches and 12 inches respectively, and speed of 950 RPM, has a brake mean effective pressure of 164 PSI. The specific fuel consumption is 0.39 pound per brake horsepower hour, and the fuel heating value is 18,500 BTU per hour. Determine the thermal efficiency. So, ito yung mga given. We have 4-stroke. Therefore, K is 1/2. 8 cylinders. Diameter 9 inches. Ang stroke 12 inches. Revolution 950 per minute. Brake mean effective pressure 164 PSI. Then, yung brake fuel consumption, 0.39 pound per brake horsepower hour. Makikita mo yun sa unit sa given, naka-brake horsepower. Heating value, 18,500 BTU per pound. Ang required is the brake thermal efficiency. Okay do, hindi sinabi sa problem na brake, hindi naman natin yan ma-identify indicated. So, there's no way na mapapunta natin sa indicated dahil ang given, panay brake, kaya brake thermal efficiency. At ang formula natin would be brake power over heat supplied. Kung saan, ang heat supply natin, this is the formula. Ngayon, pag pinalitan mo yung heat supply, eto na yung ating brake thermal efficiency. And mapapansin natin, meron tayong power and mass ng fuel. Tandaan, ang fuel consumption brake is mass ng fuel over brake power. Ibig sabihin, yung nandito sa formula na to, reciprocal ng fuel consumption. Kaya pwedeng ganito natin siya kunin. Therefore, yung iba palang given dito, hindi na natin kailangan. Although, pwede mo naman yan idaan sa isa pang way. Kukunin mo yung brake power. So, kakailangan mo pa rin yung ibang given. So, kaya lang ito, mas mabilis ito. So, substitute na natin. Then, magka-cancel yung pound. Then, hindi pa mapapalabas yung unit kasi ang efficiency unitless. So, we have the conversion, 2545 BTU per hour in 1 horsepower. Magka-cancel ang BTU, cancel ang R, cancel ang horsepower. Lalabas ang brake thermal efficiency, 0.3527 multiplied by 100%, we have 35.27%. Number 5. The area of an indicator diagram taken of a 4-cylinder, single-acting, 4-stroke engine running at 5.5 revolution per second is 390 mm square. The length is 70 mm and the scale of the indicator spring is 1 mm is to 80 kilopascal. The diameter of the cylinders is 150 mm and the stroke is 200 mm. what is the indicated power of the engine. So yung given, we have the 4 cylinders, piston action 1, 4-stroke natin, K is 1/2, revolution 5.5 per second na. Ang diameter binigay 150 mm, that is 0.15 meter. Length or stroke 200 mm, that is 0.2 meter. And binigay rin yung data ng indicator diagram. We have the area, 390 mm square. Ang length, 70 mm. Ang scale is 80 kilopascal into 1 mm. Okay, so ganun natin isulat. Kasi yung indicator, ano bang ginagawa niya? Pinimeasure yung pressure, kaya dapat sa scale, nasa taas ang pressure. The required is the indicated power, and ang solution natin, pressure times the volume displaced. Okay, pinalitan na lang natin yung volume displaced. Then, ang mean effective pressure, hindi binigay sa problem, binigay ang data ng indicator. So, this is the formula. Kunin muna natin yung pressure, so substitute natin. Wala na tayong problema sa unit kasi ang unit ay millimeter at kilopascal. Kalalabas sa pressure, 445.71 kilopascal. Indicated pressure yan. Therefore, ang ating power now, substitute na natin, lalabas ang 17.33 kilowatts.